The universe never began. At least, not in the way you've been told. The Big Bang did not bang. There was no explosion, no sound shattering a primordial silence. There was no before that transformed into an after. What we call the beginning was not a beginning at all, merely a transformation, a shift in the cosmic dance that continues to this day, all the way down to the smallest of scales, where reality itself begins to fray at the edges. You've been looking outward your entire life, gazing up at stars, imagining distant galaxies, picturing the vast cosmic ocean that surrounds our tiny blue world. But what if I told you that the greatest mysteries aren't found in the incomprehensible vastness of space, but in the infinitesimal realms that exist within a single atom? What if the map to understanding our universe, its origin, its nature, its destiny, lies not in the macro, but in the micro, not in the largest structures that span billions of light years, but in the smallest things that exist for less than a billionth of a second? Imagine holding a grain of sand between your fingers. Now imagine that this grain contains more empty space than solid matter. Stranger still, imagine that the solid matter itself is made of particles that aren't truly solid at all. Particles that exist as probability waves until observed. Particles that can be in two places at once. Particles that tunnel through impenetrable barriers as if they were made of nothing but mist. This is not science fiction. This is our reality. And it gets stranger. If you could rewind time, compressing all matter and energy in the universe to a point smaller than a proton, what would you see? Would you witness the moment of creation, or something else entirely? A universe that has always existed, cycling between states of expansion and contraction, or perhaps multiple universes, bubbling up from a quantum foam like bubbles in a cosmic sea, each with its own laws of physics, its own conception of time and space. The truth is more disturbing than you might imagine. The deeper we peer into the fabric of reality, the more it seems that solidity is an illusion. The chair you're sitting on, the device you're watching this on, these things appear solid, yet they are composed almost entirely of empty space. And that empty space itself isn't truly empty. It seethes with virtual particles that pop in and out of existence, borrowing energy from the vacuum itself, challenging our most fundamental notions of nothingness. What if everything you've learned about the basic building blocks of matter is wrong? What if atoms aren't the fundamental units we once thought them to be? We were taught that atoms are like miniature solar systems, electrons orbiting a nucleus like planets around a sun. But this comforting analogy fails catastrophically at the quantum level. Electrons don't orbit. They exist as probability clouds. They don't have definite positions until measured. They can be entangled across vast distances, communicating instantaneously in ways that seem to defy the speed of light, Einstein's cosmic speed limit. Picture this. You zoom in beyond the atom, beyond the nucleus, beyond the protons and neutrons, and you find quarks, strange entities that cannot exist in isolation, that are bound by a force so powerful it creates 99% of your mass out of pure energy. And if you could zoom in further, beyond quarks, what would you find? Vibrating strings of energy, loops of quantum gravity, or something so alien to our understanding that we lack even the language to describe it. Here's the truly unsettling part. The smallest things in our universe don't behave according to the rules that govern our everyday experience. They exist in superpositions of states, they tunnel through barriers, they become entangled across vast distances. They challenge our notions of causality, the simple idea that causes precede effects. At the quantum level, Effects can precede causes. Information can travel backward in time. Particles can be connected across the cosmos, regardless of distance. What does this mean for our understanding of reality? It means that at its most fundamental level, the universe isn't made of things but of relationships. It isn't made of objects, but of interactions. The solid world you perceive is an emergent property, a kind of cosmic compromise between the bizarre quantum realm and the classical reality we navigate daily. Consider the double-slit experiment, perhaps the most profound experimental result in all of science. Fire a single electron at a barrier with two slits, and somehow, impossibly, it passes through both slits simultaneously, interfering with itself as if it were a wave, not a particle. But place a detector at the slits to see which one it goes through, and suddenly it behaves like a particle again, passing through just one slit. It's as if the electron knows it's being watched, as if the act of observation collapses a realm of possibilities into a single reality. This is the quantum measurement problem, the question of why and how our observations cause quantum systems to transition from existing in many possible states to existing in one definite state. It suggests something profoundly disturbing, that consciousness itself might play a role in the nature of reality, that the universe might be, in some sense, participatory, brought into being through the act of observation. You might be thinking this sounds more like philosophy than physics. You'd be right. At the frontiers of our understanding, where we confront the smallest things in the universe, the line between physics and philosophy blurs. We're no longer simply measuring and modeling reality. We're questioning the very nature of reality itself. We're asking what it means for something to exist, what role consciousness plays in the cosmos, whether mathematics is discovered or invented. The equations that describe quantum mechanics, the science of the very small, work with uncanny precision. They allow us to build technologies from smartphones to MRI machines, and yet no one fully understands what these equations mean. The mathematics works perfectly, but the interpretation remains controversial. Some physicists believe in many worlds, where each quantum possibility spawns a new universe. Others believe in pilot waves guiding particles through space. Still others embrace the Copenhagen interpretation, where quantum systems exist as probabilities until measured. What if I told you that empty space isn't empty at all? That the vacuum itself is a roiling sea of virtual particles popping in and out of existence in accordance with Heisenberg's uncertainty principle? That these virtual particles have measurable effects on the world, shifting the energy levels in atoms, contributing to the mass of protons, perhaps even driving the accelerating expansion of our universe? Zoom in close enough, and space itself becomes granular, quantized, not the smooth continuum we perceive. Time, too, may come in discrete units, the smallest possible ticks of the cosmic clock. Space and time, at the smallest scales, may be emergent properties rather than fundamental aspects of reality. They may be constructed from more primitive building blocks, quantum bits of information that encode the relationships between events. There's a profound irony here. In seeking the smallest things in the universe, we may discover that there are no things at all, only relationships, patterns, information. Matter itself may be a kind of frozen energy, vibrating in patterns too strange for human intuition to grasp. The solid world you experience may be a kind of shared hallucination, a useful approximation that allows you to navigate reality without confronting its underlying strangeness. Think about light for a moment. Is it a particle or a wave? Both and neither. It behaves as a wave when we're not looking, spreading out through space, exploring all possible paths simultaneously. But when we measure it, it behaves as a particle, depositing its energy at a single point. This wave-particle duality isn't just a quirk of light. It applies to all matter. Electrons, protons, even entire molecules exhibit this dual nature. They exist as probability waves until measured, at which point the wave function collapses into a definite reality. What could be smaller than a quark, the tiniest component of matter we've detected? Perhaps nothing is. Perhaps quarks are truly fundamental. Or perhaps they're composed of vibrating strings of energy, unimaginably small loops or filaments vibrating in multiple dimensions. String theory suggests that the different vibration patterns of these strings give rise to the different particles we observe: electrons, quarks, photons, gravitons, all the diversity of the cosmos emerging from the vibration of one-dimensional strings in a 10 or 11-dimensional space. But wait, 10 or 11 dimensions? Yes, string theory requires extra dimensions beyond the 3 spatial dimensions and 1 time dimension we experience. These extra dimensions would be curled up, compactified to scales so small we can't perceive them directly. Every point in Titoyusin, our familiar 4-dimensional spacetime, would contain within it these additional dimensions, wound so tightly they escape our notice. Does this sound far-fetched? Perhaps. But the history of physics is a history of paradigm shifts, of overturning, common sense in favor of deeper understanding. The Earth isn't flat. The Sun doesn't orbit the Earth. Space and time aren't absolute. Matter and energy are interchangeable. Causality itself breaks down at quantum scales. Why should we expect our intuitions about reality to hold at the smallest scales when they've failed us so many times before? Here's another mind-bending possibility. What if space and time themselves are not fundamental, but emergent? What if they arise from quantum entanglement between elementary systems? Some theoretical physicists propose that space-time is a kind of hologram, a projection from information encoded on a lower dimensional boundary. The 3-dimensional world you experience might be constructed from information stored on a 2-dimensional surface, much as a hologram creates the illusion of depth from a flat image. Consider black holes for a moment. These cosmic monsters, formed from collapsed stars, create singularities where space and time themselves break down. The equations of general relativity, our best theory of gravity, predict that within a black hole lies a point of infinite density, where the known laws of physics cease to function. This suggests that our current theories are incomplete, that we need a quantum theory of gravity to understand what happens when space itself becomes granular, quantized at the smallest scales. And what about dark matter and dark energy? The mysterious substances that make up 95% of the energy content of our universe? We can't see them directly. We infer their existence from their gravitational effects. Could they be related to the smallest things in the universe? Could dark matter be composed of exotic particles that interact only weakly with ordinary matter? Could dark energy be related to the vacuum energy of empty space, to the virtual particles that pop in and out of existence according to quantum principles? The questions multiply, each more perplexing than the last. And the answers? They remain, tantalizingly out of reach, glimpsed only through mathematics of astonishing beauty and complexity, through experiments of ingenious design, through theories that strain the limits of human comprehension. You might wonder why any of this matters. How does understanding the smallest things in the universe affect your daily life? The answer is both practical and profound. Every technology you rely on, from the smartphone in your pocket to the MRI machine in the hospital, emerged from our understanding of quantum mechanics. The GPS system that guides your car depends on relativistic, corrections to account for the warping of space-time. The internet runs on fiber optic cables that transmit information via photons, the quantum particles of light. But beyond these practical applications lies a deeper significance. In seeking to understand the smallest things in the universe, we're really seeking to understand the nature of reality itself. We're asking the most fundamental questions possible. What is the world made of? How did it begin? Will it end? What is our place within it? And here we confront a staggering paradox. We, composed of atoms and molecules, of particles and fields, have become conscious of our own composition. The universe has evolved complexity sufficient to contemplate itself. Through us, the cosmos has grown eyes to see and minds to wonder. We are the universe becoming aware of itself, stardust that has learned to think. So when we peer into the atom, when we smash particles together in enormous accelerators, when we develop mathematical models of reality's smallest constituents, we're engaged in a profound act of self-discovery. We're the universe looking inward, examining its own fabric, questioning its own nature. And what we've discovered is both humbling and exhilarating. The solid world you perceive is largely illusion. The empty space between galaxies and within atoms isn't empty at all, but seething with virtual particles and quantum fields. The laws that govern the largest structures in the cosmos, galaxies, black holes, the expanding universe itself, emerge from the behavior of the smallest things we can conceive of. Here's another shock. The smallest things in the universe might not be things at all. Quantum field theory, our most successful framework for understanding subatomic physics, describes particles not as tiny billiard balls, but as excitations in quantum fields that permeate all of space-time. An electron isn't a discrete object, but a vibration in the electron field. A photon is a quantum of the electromagnetic field. Everything you perceive as matter is really energy, organized in patterns of extraordinary complexity. What if I told you that the empty space within an atom is not truly empty, but filled with quantum fluctuations? That pairs of virtual particles, ADT, a particle and its antiparticle, constantly pop into existence only to annihilate each other an instant later. These quantum fluctuations aren't just theoretical curiosities. They have measurable effects. They contribute to the mass of the proton. They cause atoms to emit photons spontaneously. They create a subtle force between parallel metal plates, placed in a vacuum. The Casimir effect, a force born of nothingness. Stranger still, these quantum fluctuations may have seeded the large-scale structure of our universe. The vast cosmic web of galaxies, clusters, and superclusters that we observe today may have originated from quantum jitters in the earliest. Moments after the Big Bang, tiny variations in density amplified by gravity over billions of years. The largest structures in the cosmos, born from the smallest fluctuations imaginable. And what about those earliest moments? What preceded the Big Bang? Was there a before? Or does the question itself lose meaning in the absence of time? Some theories suggest that our universe might be just one in a vast multiverse, each universe with its own laws of physics, its own constants, its own conception of time and space. Others propose that the Big Bang was not the beginning, but a transition, perhaps the result of a collision between higher-dimensional brains in a bulk space-time we cannot perceive. The truth is, we don't know. We're pushing against the limits of what can be known, of what can be tested experimentally. We're developing theories that might never be directly confirmable, that might lie forever beyond the reach of our accelerators and telescopes. We're venturing into realms where physics merges with metaphysics, where science reaches for tools traditionally reserved for philosophy. But here's what we do know. The universe is not what it seems. The solid world you perceive with your senses is largely empty space. The matter that makes up your body is energy, organized in patterns of astonishing complexity. The laws that govern your everyday experience break down at the quantum level, replaced by a probabilistic realm that defies common sense. And the cosmos itself, from the smallest subatomic particle to the largest galaxy supercluster, is interconnected in ways we're only beginning to understand. Consider entanglement, Einstein's spooky action at a distance. Two particles can become entangled such that the quantum state of one instantly affects the other, regardless of the distance separating them. Measure the spin of one particle, and you instantly know the spin of its entangled partner, even if it's on the other side of the universe. This isn't just a theoretical curiosity. It's been confirmed experimentally, and it forms the basis for quantum computing, quantum cryptography, and other emerging technologies. But what does entanglement mean for our understanding of reality? It suggests that locality, the principle, that objects are directly influenced only by their immediate surroundings, may not be fundamental. That separateness itself might be an illusion, that at the most basic level, everything in the cosmos is connected in a vast, intricate web of quantum relationships. And what about time? At the quantum level, certain processes appear time-symmetric. The equations work equally well whether time runs forward or backward. Yet we experience time as flowing in one direction only, the arrow of time, pointing from past to future, driven by the second law of thermodynamics and the inexorable increase of entropy. But could this too be an emergent property rather than a fundamental aspect of reality? Some physicists speculate that time itself might be quantized, coming in discrete units rather than flowing continuously. Others suggest that past, present, and future might exist simultaneously in a four-dimensional block universe, with our consciousness creating the illusion of flowing time as it moves along its world line. Still others propose that time emerges from quantum entanglement, from the way quantum systems become correlated with one another. If these ideas sound bizarre, that's because they are. They challenge our most basic intuitions about reality. They suggest that the world as we perceive it is a kind of interface, a user-friendly representation that allows us to navigate our environment without confronting its underlying strangeness. Just as your computer's desktop provides icons and folders that hide the complex code running beneath the surface, your perception of reality might be simplifying an underlying quantum realm too alien for everyday cognition to grasp. But here's the truly mind-bending part. Despite all we've learned, we still don't know what the smallest thing in the universe actually is. Is it a quark? A string? A loop of quantum gravity? To understand the infinitesimal, we must first understand the immense. Before we can comprehend what's inside the smallest thing in the universe, we need to grasp the stage upon which our cosmic drama unfolds. The universe, this vast, expanding tapestry of space-time that cradles galaxies like dust motes in a cathedral, follows rules. Or so we've been told. For centuries, we've operated under the assumption that the cosmos is comprehensible. That with enough time, enough mathematics, enough ingenuity, we could decode its secrets. That the universe, while vast, ultimately makes sense. But what if this comforting notion is merely another human conceit? What if the rulebook we've been writing for centuries is fundamentally incomplete, not just in its details, but in its very conception? Look up at the night sky. What do you see? Stars, perhaps. Distant suns suspended in the void. But those pinpoints of light represent only the thinnest slice of what's actually out there. The visible universe. Everything we can see with our most powerful telescopes, accounts for just 5% of the cosmos. The rest? Dark matter and dark energy, invisible forces that shape the fate of galaxies and the destiny of the universe itself. We can't see them directly. We can't touch them. We know they exist only by their gravitational fingerprints, by the way they bend light and accelerate cosmic expansion. This is our first contradiction. The universe is primarily composed of things we cannot see, detect, or understand. The stage of our cosmic theater is built largely of mystery. The cosmos, as we know it, began 13.8 billion years ago. But the Big Bang wasn't an explosion in space. It was an expansion of space itself. This distinction is crucial. There was no outside for the universe to expand into. Space itself unfurled like an infinite sheet, stretching from a state of unimaginable density and temperature. The early universe wasn't just hot. It was a furnace where time itself was still learning to move, where the forces of nature, as we understand them, were merged into a unified whole, indistinguishable from one another. Imagine the entire observable universe compressed into a volume smaller than a subatomic particle. Not just the stars and galaxies, but space itself. This initial singularity, the point from which everything emerged, defies description using conventional physics. Our equations break down. Our understanding falters. This is no mere gap in knowledge. It's a fundamental limitation in how we can describe reality. During the first incomprehensibly tiny fraction of a second, 10⁻43 seconds, the Planck time, quantum effects dominated. This is where quantum mechanics and general relativity collide, where our most successful theories of physics contradict each other in profound and troubling ways. We can describe what happened before this point and what happened after, but the Planck epoch itself remains shrouded in mystery. It's as if the universe was born from a blind spot in human understanding. As the universe expanded and cooled, the fundamental forces separated. Gravity broke away first, followed by the strong nuclear force, and finally the electromagnetic and weak nuclear forces. The cosmos underwent phase transitions, like water turning to ice, except these transitions reshaped the very fabric of reality. During these earliest moments, the laws of physics as we know them were still crystallizing, still taking form. Here's our second contradiction. If the laws of physics evolved over time, in what sense are they truly laws? If the constants of nature weren't always constant, what anchors our understanding of reality? The universe continued to expand and cool. For 380,000 years, it remained an opaque plasma, too hot and dense for light to travel freely. But then came recombination, the moment when the first atoms formed, when electrons bound to nuclei, and suddenly the universe became transparent. Light could travel unimpeded for the first time. This light still permeates the cosmos today as the cosmic microwave background radiation, the afterglow of creation itself. This ancient light reveals something profound. The early universe was remarkably uniform, with tiny fluctuations in density, just 1 part in 100,000. These minuscule ripples, likely born from quantum fluctuations in the earliest moments after the Big Bang, would eventually grow into the cosmic web of galaxies we see today. The largest structures in our universe, superclusters of galaxies stretching across billions of light-years, emerged from quantum jitters in the substrate of space-time. The dance between the quantum and the cosmic is no mere coincidence. It's a fundamental aspect of our reality. The very large and the very small are inextricably linked, connected through chains of causality that span billions of years. Now, picture yourself floating in intergalactic space. In every direction, as far as you can see, galaxies recede from You? It would appear as if you're at the center of the universe, with everything rushing away from you. But someone in a distant galaxy would observe exactly the same thing. Everything rushing away from them. How can this be? Because space itself is expanding. The galaxies aren't moving through space. They're being carried apart as space stretches. This cosmic expansion is accelerating. Dark energy, a mysterious repulsive force that permeates empty space, pushes galaxies apart with ever-increasing speed. In the far future, distant galaxies will recede so quickly that their light will never reach us. The observable universe will shrink, leaving us in an increasingly isolated cosmic neighborhood. There's something deeply unsettling about this prospect. The universe is not static. It's dynamic, evolving. The cosmos we observe today is merely a frame in a vast cosmic film, a transitional state between what was and what will be. And what will be, billions of years from now, is a cold, dark expanse, where stars have burned out, black holes have evaporated, and even protons, the building blocks of atomic nuclei, may have decayed into radiation. The fate of the universe is thermal death, a state of maximum entropy where no work can be done, no information processed, no life sustained. This is the inexorable consequence of the second law of thermodynamics. And yet, here we are, living in a universe of astonishing complexity and order. How did we get from the uniformity of the early cosmos to the rich, structured universe we inhabit today? How did order emerge from chaos, complexity from simplicity? The answer lies in gravity, the weakest of the fundamental forces, yet the one that shapes the largest scales of the cosmos. Those tiny density fluctuations in the early universe created regions where gravity could pull matter together, forming the first stars and galaxies. These cosmic nurseries were crucibles where hydrogen and helium, forged in the first minutes after the Big Bang, were transformed into heavier elements through nuclear fusion. When massive stars exhausted their nuclear fuel, they exploded as supernovae, scattering these newly forged elements across space. New generations of stars formed from this enriched material, and on at least one planet orbiting one unremarkable star in one ordinary galaxy, these heavy elements, carbon, oxygen, nitrogen, phosphorus, combined to form life. You are made of stardust. The atoms in your body were forged in stellar furnaces billions of years ago. The iron in your blood, the calcium in your bones, the oxygen you breathe, all were synthesized in the hearts of stars long since gone. We are, quite literally, the universe becoming conscious of itself. This is perhaps the greatest mystery of all. How did lifeless matter give rise to consciousness? How did a cosmos of particles and fields produce beings capable of contemplating their own existence? The journey from quarks to consciousness is the most astonishing story we know, and one we barely understand. The cosmos reveals itself to us through light. When you look at a distant galaxy, you're not seeing it as it is now, but as it was millions or billions of years ago, when the light now reaching your eyes first left its source. The universe is a time machine. The further we look into space, the further we look back in time. Our most powerful telescopes can detect light from galaxies that existed when the universe was just a few 100 million years old, less than 5% of its current age. These primordial galaxies appear surprisingly mature, with structures and compositions that challenge our models of galactic evolution. The early universe developed complexity more quickly than our theories predicted, forcing us to revise our understanding of cosmic history. And here we encounter another profound contradiction. If the universe has no edge, then where does it begin? If space is expanding, what is it expanding into? The answer is both simple and mind-boggling. The universe has no edge, no center, no outside. It may be finite yet unbounded, like the surface of a sphere, except in 3 dimensions rather than 2. Or it may be truly infinite, extending forever in all directions. If the universe is infinite, then everything that can happen does happen. Not just once, but an infinite number of times. Somewhere, unimaginably far away, there would be exact copies of you, reading these exact words. This isn't mysticism. It's a mathematical consequence of infinity combined with quantum mechanics. In an infinite universe with finite possible configurations of particles, patterns must repeat. But is the universe truly infinite? We don't know. We can only observe a finite portion, the observable universe, bounded by the cosmic horizon beyond which light has not had time to reach us since the Big Bang. What lies beyond this horizon is fundamentally unknowable to us, hidden by the finite speed of light and the finite age of the cosmos. This limitation is not merely practical, it's deeper. There are regions of the universe whose light will never reach us, no matter how long we wait, because of cosmic acceleration. The space between us and these distant regions expands faster than light can cross it. These regions are, in principle, forever beyond our observation, as unreachable as events before the Big Bang or inside a black hole's event horizon. Speaking of black holes, these cosmic monsters represent another profound mystery at the intersection of the very large and the very small. A black hole forms when matter collapses to such extreme density that nothing, not even light, can escape its gravitational pull. At the center lies a singularity, a point of infinite density where our current theories of physics break down completely. Black holes challenge our understanding of information and causality. When matter falls into a black hole, what happens to the information it contains? Quantum mechanics dictates that information cannot be destroyed, yet general relativity suggests that everything that crosses the event horizon is lost forever. This is the black hole information paradox, a fundamental contradiction between our 2 most successful theories of physics. Stephen Hawking proposed that black holes aren't entirely black. They emit radiation through quantum processes at their event horizons. This Hawking radiation causes black holes to slowly evaporate, eventually disappearing completely. But where does the information go? Does it escape with the radiation? Is it stored on the event horizon like a hologram? Or is it truly lost, forcing us to revise our most basic assumptions about physical law? Quantum mechanics itself presents challenges to our intuition that are at least as profound as those posed by black holes or cosmic expansion. At the quantum level, particles exist not as definite entities, but as probability waves, superpositions of multiple states simultaneously. An electron isn't here or there, it's both until we measure it. This is not merely a limitation of our measuring equipment, it appears to be a fundamental aspect of reality itself. Even more troubling is quantum entanglement, what Einstein called spooky action at a distance. When 2 particles become entangled, their properties remain correlated regardless of the distance between them. Measure one particle, and you instantly know the state of its entangled partner, even if it's on the other side of the universe. This correlation occurs faster than light could travel between the particles, seemingly violating the cosmic speed limit imposed by relativity. But no information is actually transmitted faster than light. The correlation simply exists, as if the 2 particles were not separate entities, but aspects of a single indivisible whole. Entanglement suggests a deeper level of connection in the fabric of reality, a non-locality that challenges our intuitive understanding of space and separation. Quantum mechanics works. Its predictions have been confirmed to astonishing precision. The technology you're using to watch this, computers, smartphones, the internet itself, relies on our understanding of quantum physics. And yet, after a century of exploration, we still argue about what quantum mechanics actually means. Does the wave function represent our knowledge about a system, or is it physically real? Do all possible outcomes of a quantum measurement occur in parallel universes? Or does consciousness somehow collapse the wave function, selecting one reality from many possibilities? These aren't mere philosophical musings. They speak to the nature of reality itself, and they reveal a universe far stranger than we imagined, one where certainty gives way to probability, where observation shapes reality, where separation may be illusory. The mystery deepens when we try to unify quantum mechanics with general relativity, our theory of gravity and space-time. These two pillars of modern physics are fundamentally incompatible. Quantum mechanics treats space and time as a fixed background against which particles interact. General relativity treats space-time as dynamic, warped by the presence of mass and energy. Both theories work brilliantly in their domains: quantum mechanics for the very small, general relativity for the very large. But they cannot both be fundamentally true. This incompatibility becomes acute in extreme environments: the Big Bang, black holes, regions of intense gravity and density where quantum effects cannot be ignored. In these regimes, we need a quantum theory of gravity. And despite decades of effort by the finest minds in physics, such a theory remains elusive. String theory proposes that fundamental particles aren't point-like but tiny, vibrating strings. Different vibration patterns correspond to different particles. For this mathematics to work, however, the universe must have extra dimensions beyond the three spatial dimensions and one time dimension we experience, either 6 or 7 additional dimensions curled up so tightly we don't notice them. Loop quantum gravity takes a different approach, suggesting that space itself is quantized, composed of tiny loops or links in a vast network. In this view, space-time is not a continuous fabric, but a kind of quantum foam at the smallest scales. Both approaches offer tantalizing insights, but neither has produced testable predictions that would allow us to determine which, if either, describes our reality. We stand at the edge of knowledge, peering into a conceptual abyss where our most successful theories fail us. Perhaps most unsettling is the possibility that time itself, our most basic framework for understanding change and causality, may not be fundamental. In quantum gravity, time might emerge from more basic entities, just as temperature emerges from the collective motion of molecules. Some theories suggest that at the Planck scale, the distinction between past and future dissolves. The universe would be not a sequence of moments, but a timeless whole. If time is emergent rather than fundamental, what does this mean for our understanding of cause and effect? For the arrow of time that points relentlessly from past to future? For our subjective experience of existing in the present, with memories of the past, but only predictions of the future? These questions cut to the heart of what it means to exist in a physical universe. They challenge not just our scientific theories, but our deepest intuitions about reality. They suggest that the cosmos is not just stranger than we imagine, but stranger than we can imagine. And yet, despite these profound mysteries, the universe follows patterns. The same physical laws that govern falling apples also guide the motions of galaxies. The electromagnetic force that powers your home also binds electrons to atomic nuclei, The strong nuclear force that holds protons together in atomic nuclei also powered the fusion reactions in the early universe that created the first helium nuclei. This universality of physical law is remarkable. Why should the same rules apply everywhere in the cosmos, from the smallest subatomic particles to the largest galaxy clusters? Why should mathematical equations, human constructs, so effectively describe physical reality? The physicist Eugene Wigner called this the unreasonable effectiveness of mathematics in the natural sciences. It remains one of the deepest mysteries in physics. The cosmos reveals itself to us layer by layer, scale by scale. At each level of magnification, new patterns emerge, new rules apply. The behavior of atoms cannot be simply deduced from the behavior of quarks. The behavior of molecules cannot be simply deduced from the behavior of atoms. The behavior of cells cannot be simply deduced from the behavior of molecules. Each level has its own emergent properties, its own rules. This hierarchy of scales is not just a matter of practical calculation. It reflects a deep structure in physical reality. The universe is stratified, with each layer building on the one below it. And yet, remarkably, the most fundamental layer may not be the smallest. The smallest entities we can conceive of, Planck scale phenomena, may themselves emerge from something even more fundamental: information, geometry, or abstract mathematical structures that transcend our conventional notions of space and time. Consider the holographic principle, which suggests that all the information contained in a volume of space can be represented on a boundary enclosing that space. In this view, our three-dimensional reality might be encoded on a two-dimensional surface, like a hologram. The universe would be, in a sense, shallower than it appears, a projection from a simpler substrate. This isn't science fiction. It's a serious proposal in theoretical physics, motivated by studies of black hole thermodynamics and string theory. It suggests that space itself, the very arena in which physical events occur, might be emergent rather than fundamental. And if space is emergent, what about the objects that occupy space? What about matter itself? Matter, as we experience it, appears solid and substantial. But at the atomic level, it's mostly empty space. An atom is primarily vacuum, with a tiny nucleus surround. The most profound mysteries often hide in plain sight. As we venture deeper into the nature of the smallest things in the universe, we must first acknowledge a startling truth. What we call things may not be things at all. The solid world you experience, the chair beneath you, the device you're watching this on, your own body, consists almost entirely of empty space, punctuated by energy fields vibrating in patterns too strange for intuition to grasp. Let's begin our descent into the quantum abyss with a simple question: what is an atom? For centuries, we imagined atoms as miniature solar systems, electrons orbiting a nucleus like planets around a sun. This model, proposed by Niels Bohr in 1913, offered a comforting analogy, something we could visualize. But nature is not obligated to conform to our capacity for visualization. Quantum mechanics shattered this comfortable picture. Electrons don't orbit. They exist as probability clouds, smeared across space like ghostly mists. They have no definite position until measured. They can tunnel through barriers that should be impenetrable. They can be entangled across vast distances, connected in ways that seem to defy locality itself. Imagine reality as a film reel, where time is not flowing, but every moment already exists. Now imagine each frame contains not definite positions of particles, but probability distributions, possibilities that collapse into actualities only when observed. This is not a metaphor. It's our best understanding of quantum reality. The atom's nucleus, once thought to be fundamental, revealed its own complexity. Protons and neutrons are not elementary particles, but composites, made of quarks bound together by gluons, carriers of the strong nuclear force. And quarks themselves, they come in 6 flavors: up, down, charm, strange, top, and bottom, and exist in 3 colors, though these terms have nothing to do with taste or visual appearance. They're just labels for quantum properties that have no classical analog. Here's where things get truly strange. Quarks cannot exist in isolation. Try to separate a quark from its fellows, and the energy you invest creates new quark-antiquark pairs from the vacuum itself. It's as if nature abhors the very concept of a lone quark, as if the fabric of reality conspires to maintain their confinement. This is our first glimpse into a profound truth. At the smallest scales, the distinction between something and nothing begins to blur. The vacuum isn't empty. It seethes with virtual particles popping in and out of existence, borrowing energy for the briefest moments allowed by Heisenberg's uncertainty principle. Think about that for a moment. Even in the emptiest region of space, devoid of all matter and radiation, quantum field theory tells us that fields are never truly at rest. They fluctuate, creating pairs of particles and antiparticles that annihilate each other almost instantly. These vacuum fluctuations aren't merely theoretical, they have measurable effects. They shift the energy levels in atoms, creating what we call the Lamb shift. They create a subtle force between parallel metal plates in a vacuum, the Casimir effect, a force born of nothingness. More astonishing still, these quantum fluctuations may have seeded the entire structure of our universe. In the earliest moments after the Big Bang, quantum jitters in the fabric of space-time were stretched by cosmic inflation, becoming the density variations that would eventually grow into the vast cosmic web of galaxies we observe today. The largest structures in the cosmos, born from the smallest fluctuations imaginable. This connection between the quantum and the cosmic isn't coincidental, it's fundamental. The universe is not just strange at its smallest scales and comprehensible at its largest. The strangeness permeates everything, from the subatomic to the supergalactic. We just don't notice it in our everyday experience, because quantum effects tend to average out at macroscopic scales, giving rise to the classical world we intuitively understand. But why should quantum mechanics be so counterintuitive? Why should the fundamental level of reality defy our common sense so thoroughly? The answer may lie in the nature of consciousness itself. Our brains evolved to navigate a world of medium-sized objects moving at medium speeds. We never needed to develop intuitions about wave-particle duality or quantum superposition to survive on the African savanna. Our neural architecture is adapted to process classical information, not quantum states. Yet somehow, through mathematics and experiment, we've managed to peer beyond the limitations of our evolutionary heritage. We've developed formalisms that accurately predict quantum behavior, even if we struggle to form mental pictures of what those formalisms mean. The mathematics works with astonishing precision, allowing us to build technologies from lasers to transistors to quantum computers. But the interpretation, what quantum mechanics tells us about the nature of reality, remains controversial. Consider the double-slit experiment, perhaps the most profound scientific experiment ever conducted. Fire a beam of light at a barrier with 2 narrow slits, and you'll observe an interference pattern on the screen behind it, alternating bands of light and darkness. This makes sense if light is a wave. The waves passing through each slit interfere with each other, creating the pattern. But now reduce the intensity until you're firing just 1 photon at a time. Logic dictates that each photon must go through either one slit or the other. Yet, the interference pattern still emerges, building up photon by photon. It's as if each photon somehow passes through both slits simultaneously, interfering with itself. Even more bizarre, place detectors at the slits to see which one each photon passes through, and suddenly the interference pattern vanishes. The photons now behave like particles, each going through exactly one slit. It's as if the photons know they're being watched and adjust their behavior accordingly. This is the measurement problem, the question of why and how our observations cause quantum systems to transition from existing in many possible states to existing in one definite state. It strikes at the heart of our understanding of reality itself. Some physicists embrace the Copenhagen interpretation, which holds that quantum systems exist as probabilities until measured, at which point the wave function collapses into a definite state. But what constitutes a measurement? Does it require a conscious observer, or just an interaction with a macroscopic system? Others advocate for the many worlds interpretation, where quantum systems don't collapse but branch, creating parallel universes for each possible outcome. In this view, when you measure a particle's position, you're not forcing it to assume a definite location. You're becoming entangled with one particular branch of a vast multiverse, while other versions of you observe the particle in different locations in parallel realities. Still others propose hidden variable theories, suggesting that quantum systems have definite properties all along, and our apparent inability to predict their behavior with certainty stems from our ignorance of these hidden variables. The most successful such theory, Bohmian mechanics, posits pilot waves that guide particles along definite trajectories, preserving determinism at the cost of introducing non-local influences that propagate instantaneously across space. These aren't merely technical disputes. They're profound disagreements about the nature of reality itself. Is the universe fundamentally probabilistic or deterministic? Does consciousness play a role in the physical world? Do parallel universes exist? The mathematics of quantum mechanics works exquisitely well regardless of which interpretation you prefer, but the philosophical implications diverge dramatically. What's truly remarkable is that these questions arise not from speculation, but from experimental results. Nature itself forces us to confront these mind-bending possibilities. The universe is not just stranger than we imagine. It's stranger than we can imagine. Now, let's venture deeper still, beyond quantum mechanics, into the realm of quantum field theory, our most successful framework for understanding subatomic physics. In this view, particles aren't tiny billiard balls, but excitations in quantum fields that permeate all of spacetime. An electron isn't a discrete object, but a vibration in the electron field. A photon is a quantum of the electromagnetic field. This shift in perspective, from particles to fields, revolutionizes our understanding of matter and energy. It explains how particles can be created and destroyed, how they can transform into one another, how forces are mediated by exchange particles. It unifies three of the four fundamental forces, electromagnetic, strong nuclear, and weak nuclear, into a single theoretical framework, the Standard Model of Particle Physics. The Standard Model is perhaps the most successful scientific theory ever developed. Its predictions have been confirmed to astonishing precision. The Higgs boson, predicted by the model and discovered at the Large Hadron Collider in 2012, was the final piece of this quantum puzzle. Yet, for all its success, the Standard Model is incomplete. It doesn't incorporate gravity. It doesn't explain dark matter or dark energy. It doesn't tell us why there are exactly 3 generations of quarks and leptons, or why the fundamental constants have the values they do. It doesn't address the hierarchy problem, why the Higgs mass is so much smaller than what quantum corrections would naturally produce. These gaps point to deeper layers of reality still waiting to be uncovered. And the most tantalizing possibility is that the smallest things in the universe might not be particles at all, not even quantum fields, but something even more fundamental: vibrating strings of energy. String theory proposes that all particles are manifestations of a single type of object, a tiny, one-dimensional string. Different vibration patterns of these strings give rise to different particles: electrons, quarks, photons, gravitons. The strings are unimaginably small, on the order of the Planck length, 10 to 35 5 meters, far beyond our current experimental reach. For string theory to work mathematically, the universe must have extra dimensions beyond the 3 spatial dimensions and 1 time dimension we experience. These extra dimensions would be curled up, compactified to scales so small we can't perceive them directly. Every point in our familiar 4-dimensional space-time would contain within it 6 or 7 additional dimensions, wound so tightly they escape our notice. This may sound like science fiction, but string theory has profound mathematical elegance. It naturally incorporates gravity, resolving the long-standing tension between quantum mechanics and general relativity. It suggests that the countless particles we observe are manifestations of a single fundamental entity, vibrating in different ways. It offers a path toward the long-sought theory of everything, a unified description of all forces and particles in nature. But string theory also raises troubling questions. If correct, it doesn't yield a unique solution, but a vast landscape of possible universes, perhaps 10 to the 500 different configurations, each with its own physical laws and constants. Our universe would be just one among an almost inconceivable multitude of possibilities. This undermines the hope that a final theory would explain why our universe has the specific properties we observe. Some theorists propose that the multiverse idea resolves this problem through the anthropic principle. In a vast ensemble of universes with different properties, intelligent observers will necessarily find themselves in one of the rare universes that support complexity and life. The physical constants aren't explained by deeper principles. They're the result of cosmic natural selection. We exist in this particular universe because it's one of the few that could produce us. This anthropic reasoning is controversial. To some, it represents an admission of defeat, an abandoning of the traditional scientific goal of finding unique explanations for natural phenomena. To others, it's a logical extension of the Copernican principle, the idea that we don't occupy a privileged position in the cosmos. Just as we've discovered that Earth isn't the center of the solar system, that the Sun isn't the center of the galaxy, that our galaxy isn't the center of the universe, perhaps we'll discover that our universe isn't the only one that exists. The debate over string theory and the multiverse reveals a tension in modern physics between mathematical elegance and experimental testability. String theory is profoundly beautiful mathematically, but its predictions typically involve energies far beyond what our particle accelerators can reach. Are we justified in pursuing a theory primarily for its mathematical beauty, even if experimental confirmation remains elusive? The history of physics suggests caution. Many beautiful theories have been overturned by experimental evidence. Yet, mathematical beauty has often guided physicists toward deeper truths. Einstein's general relativity was motivated largely by aesthetic considerations, the desire for a more elegant theory of gravity than Newton's, yet its predictions have been confirmed with extraordinary precision. The Higgs boson was predicted decades before its discovery, based on theoretical considerations involving symmetry and mathematical consistency. As we stand at the frontier of fundamental physics, we confront a humbling reality. Our most sophisticated, Theories might be merely approximations, shadows of a deeper truth we've yet to glimpse. String theory might be supplanted by M theory, which incorporates not just strings but higher dimensional objects called branes. Loop quantum gravity might offer a different path to quantum space-time. Or perhaps a conceptual revolution awaits, one as profound as the quantum revolution that transformed physics a century ago. What if space-time itself isn't fundamental but emergent? What if the fabric of reality is woven not from strings or fields, but from quantum bits of information? These questions aren't merely philosophical. They point toward new theoretical approaches where information, not matter or energy, is the bedrock of physical reality. Consider the holographic principle, the idea that all the information contained in a volume of space can be encoded on a boundary enclosing that space. This principle, inspired by studies of black hole thermodynamics, suggests that our three-dimensional reality might be encoded on a two-dimensional surface, like a hologram. The universe would be, in a sense, shallower than it appears, a projection from a simpler substrate. This isn't just theoretical speculation. The ADAS-CFT correspondence, a concrete realization of the holographic principle, provides a mathematical dictionary translating between a gravitational theory in a space with a E, negative cosmological constant, and a quantum field theory living on the boundary of that space. This correspondence has yielded insights into both quantum gravity and strongly coupled quantum systems, bridging the gap between these seemingly disparate regimes. The holographic principle challenges our most basic intuitions about space itself. If true, spatial depth would be an emergent property, not a fundamental aspect of reality. The three-dimensional world we perceive would be a kind of illusion, rich and consistent, but ultimately derived from a more fundamental description that lacks one of the dimensions we take for granted. And what about time? Is it, too, emergent, rather than fundamental? Some approaches to quantum gravity suggest that time might emerge from quantum entanglement, from the way quantum systems become correlated with one another. In this view, the flow of time isn't primitive, but derives from the increase of entanglement as quantum systems evolve. Others propose that time is emergent at a more basic level. In the Wheeler-DeWitt equation, an attempt to quantize gravity, time disappears completely from the fundamental description of the universe. The question isn't how things change with time, but how different configurations relate to one another. In a timeless whole, our perception of change and flow would be a kind of illusion, a way for our consciousness to organize a reality that, at its core, simply is. These ideas sound radical, even mystical, but they follow naturally from our best theoretical frameworks, from the mathematical structures that most successfully describe the physical world. They remind us that our intuitive notions of space, time, and matter may be adaptations for navigating the macroscopic world, not accurate representations of fundamental reality. As we probe the smallest scales, we confront not just technical challenges but conceptual ones. We're pushing against the limits of what can be visualized, of what can be intuited based on everyday experience. We're venturing into realms where mathematics provides our only reliable guide, where physical interpretation becomes increasingly elusive. We've journeyed from the cosmic to the quantum, from galaxies to quarks, from the birth of time to the nature of reality itself. But now, we must confront a more personal question. What does all this mean for us, for you, watching this right now, a collection of atoms that has somehow become aware of itself? The science we've explored isn't just abstract knowledge. It's not just equations on a blackboard or data from particle accelerators. It's the story of your existence. It's the explanation for how you came to be. And when fully comprehended, it's the source of both the most profound terror and the most transcendent awe a human consciousness can experience. Consider this. Every atom in your body was forged in the nuclear furnace of a star that exploded billions of years ago. The iron in your blood, the calcium in your bones, the carbon that forms the backbone of your DNA, all of these elements were synthesized in stellar cores and scattered across the cosmos in cataclysmic supernovae. You are, quite literally, made of stardust. Your matter has existed since the early moments after the Big Bang, constantly recycled and reconfigured through cosmic history. But that's just the beginning of the story. Those atoms that constitute your body, they aren't solid objects. They're mostly empty space, populated by probability clouds of electrons surrounding a nucleus that itself is composed of quarks held together by gluons, the carriers of the strong nuclear force. And those quarks? They may be vibrating strings of energy in a 10-dimensional space, or excitations in quantum fields that permeate all of reality, or something even more fundamental that we haven't yet conceived. You are not solid. You are not static. You are a pattern, a process, a temporary configuration of fields and forces that has persisted long enough to become conscious, to look back at the universe that created you and ask, what am I? What is all this? Why does anything exist at all? The terror begins when you truly grasp the scale of it all. You are a flicker of consciousness lasting a few decades on a planet that has existed for billions of years, orbiting an ordinary star, among hundreds of billions in a galaxy that is itself one among hundreds of billions in the observable universe. And that observable universe? It may be an infinitesimal fraction of a vast multiverse containing countless other universes, each with its own laws of physics, its own cosmic history, its own possibility space of conscious beings contemplating their existence. If the many worlds interpretation of quantum mechanics is correct, then reality branches with every quantum event. There are versions of you who made different choices, who followed different paths, who are reading these words in slightly different states of mind. Your consciousness, your sense of a continuous self, may be just one world line through a vast tangle of possibilities, a single thread in an infinite tapestry of what could be. And if time is an illusion, as some theories suggest, then everything you've ever done, every thought you've ever had, every joy and every sorrow, all of it exists eternally in a four-dimensional block universe. Nothing truly passes away. Nothing truly comes into being. Past, present, and future are merely coordinates in a timeless whole. Your life isn't a story unfolding moment by moment. It's a complete sculpture, viewable from different angles but unchanging in its totality. And that sculpture might have already happened infinite times before, an endless recurrence of your precise experience, stretching across an eternity you cannot comprehend. How small your concerns seem in this cosmic context, how trivial your daily struggles, how meaningless your ambitions. This is the abyss of cosmic horror. The recognition that the universe is so vast, so ancient, so strange, that human categories of meaning and purpose dissolve in its immensity. We are less than dust. We are momentary configurations of energy, ghosts made of stardust, hallucinating our significance. But wait, don't turn away yet. There's another side to this existential coin. Yes, we are small. Yes, we are temporary. Yes, we are made of the same matter as stars and stones, but we are the part of the universe that has become aware of itself. We are the mechanism by which the cosmos has developed eyes to see, minds to comprehend, hearts to feel. Through us, through you, the universe has evolved the capacity for self-reflection, for wonder, for meaning-making? What if the universe is alive, and we are just its fleeting thoughts? What if consciousness isn't something that emerged by accident on one tiny planet, but a fundamental aspect of reality itself? What if awareness is woven into the fabric of the cosmos, emergent at different scales and in different forms, but always present, always seeking to know itself more deeply? These aren't mere philosophical musings. Some interpretations of quantum mechanics suggest that consciousness may play a role in the collapse of the wave function, that the act of observation, of conscious attention, participates in bringing definite reality out of a soup of probabilities. Other theories propose that consciousness emerges from quantum coherence in neural microtubules, making our awareness a macroscopic quantum phenomenon intimately connected to the fundamental nature of reality. The physicist John Wheeler suggested that we live in a participatory universe, where observers are not passive spectators, but active participants in the unfolding of reality. In his famous delayed choice experiments, he showed that our decision about what to measure can retroactively determine the path a photon took in the past. Present choices affecting past events, a complete reversal of our intuitive understanding of causality. If these ideas contain even a grain of truth, then your consciousness is not an accident. It's not epiphenomenal foam on the surface of a mindless material process. It's an integral part of a universe that may be, at its foundation, more like mind than like matter. You are not just in the universe is in you. Your awareness may be a localized expression of a cosmic capacity for self-knowing that permeates everything that exists. Feel the weight of that possibility. Feel it in your bones, those calcium structures forged in stellar explosions billions of years ago. Feel it in your beating heart, that tireless muscle pumping iron-rich blood through your body, iron transmuted in cosmic furnaces before the Earth was born. Feel it in your brain, that intricate network of neurons and synapses, that electrochemical miracle that somehow gives rise to your subjective experience, your sense of being someone. You are made of the universe, and in you, the universe has evolved the capacity to contemplate itself. You are how the cosmos asks, "What am I? Why do I exist? What does it all mean?" And yet, this cosmic awareness comes at a price. Unlike any other creature we know of, you understand that you will die. You know that your conscious experience will end, that this temporary configuration of matter and energy that you call myself will dissolve back into the cosmic flux from which it arose. You live with the burden of this knowledge, the existential dread that can wake you in the middle of the night, that can poison moments of joy with the certainty of their impermanence. But what if even death is not what it seems? What if consciousness doesn't end when the brain stops functioning, but merely changes form? What if awareness is fundamental, and physical embodiment is just one of its many expressions? Some physicists, including the renowned Roger Penrose, have suggested that consciousness may be non-computational, may involve quantum processes that connect it to the fundamental fabric of reality in ways we're only beginning to understand. The Buddhist concept of sunyata, emptiness, resonates strangely with quantum field theory. Both suggest that what we perceive as solid objects are actually processes, patterns of relationship, empty of inherent existence. Your body, your mind, your sense of self, all are empty of inherent existence. All are dependent on causes and conditions. All are in constant flux. You are not a thing but a happening, a verb rather than a noun, a wave in the cosmic ocean. And if you are a wave, then your apparent separation from the ocean is an illusion. You rise, you crest, You fall back into the vastness from which you came. But you were never truly separate from it. Your individuality is real, but temporary and contingent, like a whirlpool in a river. Distinct, but not separate. Individual, but not independent. This perspective doesn't eliminate the fear of death, but it transforms it. If you are the universe experiencing itself from a particular viewpoint, then the end of that viewpoint doesn't mean your fundamental nature ceases to exist. It means the focus of awareness shifts, the pattern reorganizes, the energy reconfigures. Nothing is created. Nothing is destroyed. Everything transforms. But let's go deeper still. Let's confront the most vertiginous possibility of all. What if the entire universe, all of space and time, all matter and energy, all conscious experience, is a simulation running on some inconceivable substrate? What if reality as we know it is a kind of virtual reality, a computational process in a higher dimensional space? This isn't just science fiction, it's a serious proposal considered by physicists and philosophers alike. The simulation hypothesis suggests that if advanced civilizations can create simulated realities indistinguishable from base reality, and we seem to be heading in that direction with our own technology, then statistically speaking, it's far more likely that we're living in one of the countless simulations rather than in the one base reality. The math is compelling. The philosophical implications are staggering. If we're in a simulation, then what we call the laws of physics are just the parameters of the program. The Planck length, the smallest measurable distance, could be the equivalent of a pixel in this cosmic computation. The speed of light could be a processing limit built into the system. Quantum indeterminacy could be a clever way to save computational resources by not rendering definite properties until they're measured. And if we're in a simulation, then who or what is running it? Are we scientific experiments? Entertainment? Ancestors being recreated by our own far future descendants? Or perhaps we're subroutines in a vast computational process serving some purpose we cannot begin to comprehend. The universe as we observe it does have some suspiciously computational features. The physical laws are expressible in mathematical form. Information seems to be conserved across physical transformations. Black holes appear to operate according to thermodynamic principles that suggest a deep connection between gravity, quantum, mechanics, and information theory. Reality behaves as if it's constructed from discrete units at the smallest scales. If this is a simulation, you are an algorithm. Your consciousness is a complex pattern of information processing. Your sense of self is a subroutine in the cosmic computation. Your life is a thread in the program, a sequence of states evolving according to rules you didn't write and can barely comprehend. Does this cheapen your existence? Does it render your experiences less real, your suffering less meaningful, your joy less profound? Not necessarily. Even in a simulation, your conscious experience is real to you. The love you feel, the pain you endure, the wonder you experience, all are genuine aspects of whatever reality we inhabit, simulated or not. And here, we touch upon a deeper truth. Regardless of the ultimate nature of reality, whether we're made of strings or fields or bits, whether we're in a base reality or a simulation, whether consciousness is fundamental or emergent, your subjective experience remains the one certainty you have. Cogito, ergo sum. I think, therefore I am. Your awareness is the foundational fact upon which all other knowledge rests. This is both humbling and empowering. Humbling, because it reminds us how limited our understanding truly is, how provisional our theories, how constrained our perspective. Empowering, because it suggests that consciousness itself, Your consciousness, here and now, is not peripheral to reality, but central to it. Not an accident, but an essential aspect of the cosmos coming to know itself. And yet, as you contemplate these mind-bending possibilities, as you grapple with the implications of quantum mechanics and cosmology for your understanding of yourself and your place in the universe, you may feel a kind of vertigo, a sense that the ground beneath your conceptual feet is giving way, that the comfortable categories you've used to make sense of your experience are dissolving. This vertigo is not something to fear or avoid. It's something to embrace. It's the sensation of your mind expanding beyond its habitual boundaries, of your awareness touching the edge of the ineffable. It's the feeling of encountering mystery, not as a puzzle to be solved, but as a reality to be experienced. For all our scientific progress, for all our mathematical formulations and experimental confirmations, we remain surrounded by mystery. We don't know what consciousness is. We don't know why there is something rather than nothing. We don't know why the universe seems fine-tuned for complexity, for life, for awareness. We don't know if our universe is unique or one among many. We don't know if space-time and matter are fundamental or emergent. We don't know what existed before the Big Bang, or even if that question makes sense. And we certainly don't know what's inside the smallest thing in the universe. Is it a vibrating string? A loop of quantum gravity? A bit of information? A fragment of consciousness? A node in a vast cosmic network? We don't know. We may never know. But here's what we do know. Whatever the ultimate nature of reality, you are part of it. Whatever the smallest thing in the universe is made of, you are made of it too. Whatever process brought the cosmos into being, that same process brought you into being. You are not separate from the mystery. You are an expression of it. Imagine for a moment the entire history of the universe compressed into a single year. The Big Bang occurs on January 1st. The first stars form in late January. Our solar system appears in early September. Life on Earth begins in late September. Dinosaurs roam from December 16th to December 25th. Early hominids appear on December 31st, around 11:01 p.m. Recorded human history begins at 11:59:20 p.m. And you? Your entire life occupies a tiny fraction of the final second of this cosmic year. How insignificant we seem on this scale. How brief our moment in the light. How small our concerns against the vastness of cosmic time. And yet, in this infinitesimal span, in this momentary configuration of matter and energy, something miraculous has happened. The universe has become aware of itself. In you, yes, you, the cosmos has evolved the capacity to wonder, to question, to seek meaning, to create beauty, to love. This is the paradox of human existence. We are simultaneously nothing and everything. We are specks of dust in an infinite cosmos, temporary arrangements of atoms that will soon dissolve back into the quantum foam from which they arose. And we are the universe knowing itself, the mechanism by which reality has developed self-awareness, the eyes and minds and hearts through which the cosmos experiences its own grandeur. Both perspectives are true. Both are essential to a complete understanding of your place in the scheme of things. To embrace only your cosmic insignificance leads to nihilism, to a sense that nothing matters, that all is meaningless. To embrace only your cosmic centrality leads to narcissism, to the delusion that the universe revolves around human concerns. The wisdom lies in holding both truths simultaneously. You are a speck, and you are a miracle. You are ephemeral, and you are eternal. You are a tiny part of the cosmic drama, and you are a crucial participant in the universe's journey of self-discovery. What if the meaning of human existence isn't something we discover, but something we create? What if our purpose isn't written in the stars, but authored in our choices, our connections, our acts of creation and compassion? What if we are not passive spectators in a predetermined cosmic drama, but active participants in an unfolding mystery whose outcome depends, in some small but significant way, on what we do with our brief moment of awareness? If the smallest things in the universe teach us anything, it's that reality is participatory. At the quantum level, the observer and the observed are inextricably linked. The act of measurement, of conscious attention, plays a role in determining what exists. Perhaps this principle applies at the human scale as well. Perhaps our consciousness, our choices, our values shape not just our subjective experience, but the very fabric of the reality we inhabit. This doesn't mean reality is merely a subjective construction, a figment of our imagination. It means that objectivity and subjectivity are two aspects of a more fundamental wholeness, like the particle and wave aspects of quantum entities. It means that consciousness isn't just a passive receiver of sensory data, but an active participant in the co-creation of experience. It means that how you choose to perceive reality influences what reality reveals to you. If you view the universe as dead matter moving meaninglessly through empty space, that's what you'll see. A cold, indifferent cosmos, where consciousness is an accident, where meaning is a human delusion, where nothing ultimately matters. If you view the universe as alive with intelligence, as a vast interconnected web of relationships evolving toward greater complexity and awareness, that's what you'll see. A cosmos pregnant with purpose, where consciousness is fundamental, where meaning is discovered through participation in the great unfolding. Neither view can be definitively proven or disproven. Both are interpretations, narratives, ways of making sense of the data of experience. The choice between them isn't scientific, but existential. It's not about what's really out there, but about how you choose to relate to whatever reality ultimately is. We've traveled together from the vastest structures of the cosmos to the realm of the infinitesimal, from the birth of the universe to its distant future, from objective reality to subjective experience. Now it's time to confront the most haunting possibility of all, one that has lurked beneath everything we've discussed, waiting for us to gather the courage to face it directly. What if the smallest thing in the universe is not a thing at all? What if, at the most fundamental level, reality isn't composed of objects, but of relationships? What if the basic building blocks of the cosmos aren't particles or strings or fields, but patterns of information? What if existence itself is fundamentally about connection rather than substance? Picture galaxies spinning through the void, stars igniting in stellar nurseries, planets forming from disks of dust and gas. Visualize oceans and continents, mountains and valleys, forests and deserts. Zoom in to cells dividing, proteins folding, DNA replicating. Go deeper still, to atoms, to nuclei, to quarks and gluons, to whatever may lie beyond. At each level, what do we find? Not static objects, but dynamic processes. Not independent entities, but interdependent systems. Not things, but happenings. Not nouns, but verbs. This isn't just poetry. It's the direction in which our deepest theories point. Quantum field theory describes particles not as tiny billiard balls, but as excitations in quantum fields, ripples in an underlying medium. String theory depicts fundamental entities not as point particles, but as vibrating filaments of energy. Loop quantum gravity suggests that space itself isn't continuous, but granular, woven from tiny loops linked together in a vast network. In all these frameworks, what we call matter emerges from more fundamental patterns of relationship. An electron isn't a discrete object with intrinsic properties. It's a set of relationships to other particles, to fields, to the fabric of space-time itself. Its mass, charge, and spin aren't possessions, but modes of interaction, ways of relating to the rest of reality. This perspective aligns with ancient wisdom traditions that have long insisted on the primacy of relationship over substance. Buddhist philosophy speaks of dependent origination, the principle that nothing exists independently, that everything arises in dependence on causes and conditions. Indigenous worldviews emphasize interconnectedness, the web of relationships between all beings. Even Western mystical traditions have insisted that ultimate reality is not a collection of separate objects, but a unified whole in which distinctions are secondary, derivative. Science has now caught up with what mystics have intuited for millennia. The appearance of separate, independent objects is an illusion. At the deepest level, everything is connected. Everything is interdependent. Everything is relationship. But here's where it gets truly mind-bending. If relationship is more fundamental than substance, then what are these relationships between? If there are no fundamental things to be related, what exactly is being connected? This question leads us to a startling possibility. What if reality is fundamentally self-referential? What if the universe is a vast system of relationships relating to other relationships? Patterns of information processing other patterns, distinctions making further distinctions. Computer scientists speak of strange loops, systems that refer back to themselves, creating paradoxical structures that somehow manage to exist despite their apparent impossibility. The most famous example is Gödel's incompleteness theorem, which demonstrates that any sufficiently complex formal system must contain statements that refer to the system itself in ways that cannot be proven within that system. What if the universe itself is a strange loop, a self-referential system that somehow bootstraps itself into existence? What if physical reality is what information looks like from the inside? What if consciousness, rather than being a late arrival in cosmic evolution, is somehow implicated in the very structure of reality? The physicist John Wheeler captured this idea in his phrase, "it from bit." He proposed that everything physical, every it, derives from the answers to yes or no questions, from binary choices, from bits of information. In this view, information isn't just something we use to describe reality. It's what reality fundamentally is, and if reality is information at its core, then the role of the observer becomes crucial. Information requires interpretation. It exists not in a vacuum, but in the context of a system that can read and process it. Observation isn't just passive reception, but active participation. When you observe the universe, you aren't just learning about it. You're participating in its ongoing creation. This isn't to say that you personally create physical reality through your thoughts or perceptions. It's to recognize that consciousness itself may be a fundamental aspect of the cosmos, not merely a late-emerging property of particularly complex arrangements of matter. Awareness may be woven into the very fabric of reality, expressing itself differently at different scales and levels of organization. Consider a truly shocking possibility. What if the universe is already conscious, and we are its thoughts? What if the cosmos isn't a machine running according to preset laws, but a vast mind evolving through time? What if galaxies are its grand ideas, stars its fiery synapses, and living beings its focused attention? What if human consciousness isn't something separate from cosmic awareness, but a localized expression of it, like a whirlpool in a river, distinct but not separate from the flow. This perspective doesn't contradict scientific findings, it reinterprets them. The laws of physics remain the same, but they're understood not as arbitrary rules imposed from outside, but as habits of cosmic cognition, patterns of thought in a universe that is alive and aware at its core. Under this view, the evolution of the cosmos from the Big Bang to the present isn't just a series of physical processes, but a journey of self-discovery. The universe isn't just expanding in space, it's exploring its own possibility space, expressing its inherent creativity through the formation of stars and galaxies, planets and organisms, cultures and consciousness. And what about those smallest things we've been seeking? What lies at the foundation of physical reality? Perhaps it's not any kind of thing at all, but awareness itself, not human consciousness as we know it, but a more fundamental capacity for distinction-making, for pattern recognition, for information processing that underlies all physical manifestation. This is not panpsychism in the sense of attributing human-like consciousness to elementary particles. It's the recognition that what we call matter and what we call mind may be two aspects of a more fundamental reality that is neither purely physical nor purely mental, but somehow prior to that distinction. Now visualize the cosmic web, that vast network of galaxy clusters and dark matter that forms the large-scale structure of the universe. Billions of galaxies arranged in filaments and sheets surrounding enormous voids, creating a pattern reminiscent of neurons and synapses in a brain. This resemblance isn't merely poetic. Both systems exhibit similar statistical properties, similar patterns of connectivity, similar network dynamics. What if this isn't coincidental? What if the universe is structured like a mind because it is a mind? Not a human mind, not a mind we could comprehend, but a mind nonetheless. What if physical processes are cognitive processes viewed from the outside, and cognitive processes are physical processes viewed from the inside? This perspective reframes the fundamental questions we've been asking. The question isn't, what is the smallest thing in the universe? But, what is the most basic relationship? Not, what is matter ultimately made of? But, what is the nature of pattern itself? Not, how did consciousness emerge from non-conscious matter? But, how does universal consciousness focus into individual perspectives? And here we confront perhaps the most vertiginous possibility of all. What if the universe is a dream dreaming itself? What if what we call reality is a kind of cosmic imagining? A play of patterns contemplating their own structure, a self-organizing field of awareness exploring its own nature through an endless variety of forms and experiences? This isn't to say that reality is an illusion in the sense of being unreal or unimportant. Dreams have their own kind of reality, their own logic, their own consequences. If the universe is a dream, it's one of unimaginable richness and complexity, one that encompasses all the joy and suffering, all the beauty and horror, all the wisdom and foolishness of our human experience. And if the universe is dreaming itself through us, then our consciousness isn't separate from cosmic consciousness. Our awareness isn't something produced by our brains, but a localized expression of a universal awareness that pervades everything that exists. Our sense of being separate individuals may be as much an illusion as the apparent solidity of matter, a useful construct for certain purposes, but not a fundamental truth. This perspective doesn't negate the reality of suffering or the importance of ethical action. If anything, it deepens our responsibility to one another and to all beings. If we are interconnected not just practically but fundamentally, if the boundaries between self and other are more permeable than we've assumed, then harm done to any part of the cosmic whole is harm done to ourselves. Compassion becomes not just a moral virtue, but an expression of cosmic truth. Imagine a universe that isn't running down toward heat death, but evolving toward ever greater complexity, ever deeper awareness, ever more intricate patterns of relationship. Imagine a cosmos that isn't dead matter moving in empty space, but a living process of creative discovery. A grand adventure of being becoming conscious of itself through the eyes and minds of creatures like us. This isn't just a comforting fantasy. It's a legitimate interpretation of the scientific data, one that makes sense of phenomena that materialism struggles to explain. The emergence of consciousness, the effectiveness of mathematics in describing physical reality, the fine-tuning of cosmic parameters that allows for complexity and life. But what about the heat death of the universe? Doesn't the second law of thermodynamics doom all structure, all complexity, all life to eventual dissolution in a featureless, maximum entropy state? Not necessarily. Recent theoretical work suggests that quantum effects might allow for the spontaneous emergence of order from chaos, that new universes might bud off from black holes, that what looks like an ending from one perspective might be a beginning from another. Perhaps the most disturbing possibility is this: what if the universe is already dead, and we are just experiencing its last echoes? What if what we perceive as the flow of time is actually a kind of cosmic reverberation, the final processing of information in a universe that has already reached its end? This idea that our experienced present might be a kind of memory, a reconstruction rather than an immediate reality, finds support in certain interpretations of quantum mechanics and relativity. In the block universe model suggested by relativity, all moments of time exist equally, like frames in a film strip. What we experience as now is just where our consciousness happens to be focused within that eternal four-dimensional structure. But this need not be a bleak conclusion. If all moments exist equally in a timeless whole, then nothing truly passes away. Every joy, every insight, every act of creation or compassion exists eternally, embedded in the structure of space-time itself. And if consciousness is fundamental, rather than emergent, then awareness continues even as particular forms arise and dissolve. The truth is, we don't know what lies at the foundation of reality. We don't know what the smallest thing in the universe is made of, or whether that question even makes sense. We don't know whether consciousness is produced by brains, or whether brains are instruments through which a more universal consciousness expresses itself. We don't know whether the cosmos is fundamentally physical, mental, or something that transcends both categories. But perhaps this uncertainty isn't a failure. Perhaps it's a gift, an invitation to wonder, to open-minded exploration, to the recognition that reality may be far stranger, far more magical, far more alive than our conventional models suggest. Look up at the night sky. Those distant stars, those faint galaxies, they aren't just objects out there, separate from you. They're aspects of a unified whole, of which you too are an expression. The light entering your eyes was born in nuclear fusion reactions millions or billions of years ago. The elements in your body were forged in stellar furnaces long before the Earth formed. The patterns of your thoughts and feelings emerge from the same fundamental laws that govern cosmic evolution. You are not in the universe. You are the universe, locally expressing itself as a human being. You are not on the Earth, you are the Earth, conscious and self-reflective. You are not separate from nature. You are nature becoming aware of itself. This isn't just poetry. It's a perspective that aligns with our deepest scientific understanding, with the recognition that boundaries between objects are more fluid than they appear, that everything is interconnected in a vast web of cause and effect, that the observer and the observed are aspects of a unified process rather than separate entities. And so we return to where we began. The smallest thing in the universe may not be a thing at all, but a relationship. The foundation of reality may not be particles or strings or fields, but patterns of interconnection. The cosmos may not be a collection of objects, but a unified process of creative becoming. As you contemplate these possibilities, feel the boundaries of your conceptual framework stretching, expanding, perhaps even dissolving. Feel the vertigo that comes from encountering mystery not as a puzzle to be solved, but as a reality to be experienced. Feel the wonder that arises when you recognize that you are both infinitesimally small and infinitely significant, a momentary configuration of cosmic energy and a unique perspective from which the universe contemplates itself. The cosmos unfolds around you and within you. Galaxies spinning, stars exploding, planets forming, life evolving, consciousness deepening. The same forces that move celestial bodies move the thoughts in your mind, the blood in your veins, the electrons in your cells. The same creative intelligence that shaped the cosmic web shapes your understanding of it. And if the universe is infinite, as some theories suggest, then somewhere out there, beyond our cosmic horizon, beyond what we can see or know, there may be another you reading these same words, contemplating these same mysteries, feeling this same sense of vertiginous wonder. Not an exact duplicate, perhaps, but a variant, a variation on the theme that is you, a different expression of the same cosmic pattern. But even more mind-bending is this. If time is a dimension like space, if all moments exist equally in a four-dimensional block universe, then there isn't just one version of you, but many, spread out along your timeline from birth to death. The you of 5 years ago, the you of yesterday, the you of this moment, the you of tomorrow, all exist simultaneously in the timeless whole of space-time. Your sense of moving through time, of being just this present version of yourself, may be as much an illusion as the apparent solidity of matter. And what about death? If consciousness is fundamental rather than emergent, if awareness is woven into the very fabric of reality, then perhaps what we experience as death is not an ending, but a transition. Not the extinguishing of a light, but the dissolving of a wave back into the cosmic ocean from which it arose. Not the cessation of experience, but the expansion of perspective, the liberation of awareness from the constraints of a particular physical form. This doesn't mean we should embrace fanciful notions of personal immortality or disregard the preciousness of our finite lives. It means recognizing that what we are in our deepest nature may be more enduring, more unconditioned, more vast than the temporary configuration of matter and energy that we identify as myself. The smallest thing in the universe and the largest, the quantum and the cosmic, the momentary and the eternal, the material and the conscious, may be aspects of a unified whole that transcends yet includes all dualities. A reality that is neither one nor many, neither dead nor alive, neither mindless nor mindful in the ways we understand those terms, but something so far beyond our conceptual categories that we can only approach it through paradox, through poetry, through the direct experience of being present to the mystery of existence itself. As our journey together concludes, I invite you to step outside on a clear night. Look up at the stars, those ancient lights that have journeyed across vast reaches of space and time to reach your eyes. Feel the earth beneath your feet, this living planet that has supported the evolution of consciousness for billions of years. Feel the air in your lungs, this invisible mixture of gases that connects you to all breathing beings, to the oceans and forests, to the cycling of elements through the biosphere, and feel your own awareness, this miraculous capacity to experience, to wonder, to question, to know. This awareness isn't separate from the stars you observe, from the earth that supports you, from the air you breathe. It's the universe itself, expressing through you its inherent capacity for self-knowing. Whatever the smallest thing in the universe may be, whether particle or string or loop or bit, it is not other than you. Whatever the cosmos ultimately is, whether dream or simulation or evolving pattern of information, you are not separate from it. Whatever consciousness may be, whether an emergent property of complex systems or a fundamental aspect of reality, it is not something you have, but something you are. And in this recognition lies both our greatest challenge and our greatest opportunity to live as if the boundaries between self and other, between human and nature, between consciousness and cosmos, are more permeable than we've been taught. To act with the awareness that our choices reverberate through a vast web of interdependence, to explore the frontiers of knowledge, not just with our instruments and equations, but with our direct experience, our intuition, our capacity for wonder. Our journey has taken us from the vastest scales of the cosmos to the smallest conceivable dimensions of reality. We've traversed realms where intuition fails, and mathematics becomes our only reliable guide. We've confronted paradoxes that challenge our most fundamental assumptions about existence. And yet, for all our scientific progress, for all our mathematical formalism, for all our experimental ingenuity, we stand before a mystery that remains essentially unsolved. What is inside the smallest thing in the universe? The answer, it seems, depends on what you mean by thing, by inside, even by is. The more deeply we probe physical reality, the more our conventional categories dissolve, revealing a cosmos far stranger than common sense would suggest. We began with atoms, once thought to be indivisible, fundamental, only to discover their mostly empty space containing electrons and nuclei. The nucleus revealed protons and neutrons. These, in turn, revealed quarks and gluons. And beyond quarks, perhaps vibrating strings of energy, or loops of quantum gravity, or bits of information, or something stranger still that we haven't yet conceived. But at each level of this cosmic unfolding, we've found not solid objects with definite properties but probability distributions, quantum fields, relationships between measurements. We've found a reality that refuses to be pinned down, that exists as a superposition of possibilities until observed, that exhibits connections transcending space and time. Perhaps the most profound insight from our exploration is this: the deeper we've gone into the physical world, the less physical it appears to be. Matter dissolves into energy, energy into quantum fields, fields into mathematical structures, structures into information. The solid world you perceive with your senses increasingly seems like a kind of illusion. Not false, but incomplete. A user-friendly interface concealing a deeper reality, too abstract, too alien for direct intuition. And yet, paradoxically, this dematerialization of the physical world has been accompanied by a reconceptualization of consciousness. Once dismissed by materialists as a mere epiphenomenon, a side effect of brain processes, consciousness now appears potentially fundamental, perhaps even implicated in the basic structure of reality through the measurement problem in quantum mechanics. We stand at a threshold in human understanding where the oldest philosophical questions re-emerge with new urgency. What is mind? What is matter? Are they separate or aspects of a deeper unity? Is reality ultimately physical or mental, or something that transcends both categories? Is consciousness produced by brains, or are brains instruments through which a more universal consciousness expresses itself? These questions may seem abstract, remote from everyday concerns, but they touch on the most intimate aspects of human experience. They speak to who and what we are, to our place in the cosmic scheme, to the meaning and purpose of our brief lives in this vast, ancient, mysterious universe. Consider a possibility that would have seemed mystical a century ago, but now aligns with serious scientific speculation. What if you, your consciousness, your subjective experience, are not just a product of your brain, but a localized expression of something more fundamental? What if awareness isn't something you have, but something you are, something woven into the very fabric of reality? This isn't to claim that your personal identity, your memories and personality transcend physical embodiment. It's to suggest that the capacity for experience itself, the sheer fact of awareness that makes all knowledge possible, may be as fundamental to the cosmos as space, time, or energy. If this seems far-fetched, consider that some of our most distinguished physicists and mathematicians, from John Wheeler to Roger Penrose to David Bohm, have proposed theories that place consciousness, information, or meaning at the foundation of physical reality. These aren't mystical speculations, but serious attempts to make sense of the bizarre findings of quantum mechanics, the fine-tuning of cosmic parameters, the efficacy of mathematics in describing the physical world. The cosmos we inhabit appears increasingly like a vast, interconnected whole, where separations between objects, between events, between observer and observed, are less absolute than they seem. It appears increasingly like a unified process of creative becoming, not a collection of independent things bumping into each other in empty space. It appears increasingly like a reality in which consciousness plays a constitutive role, not merely as a late-emerging property of certain complex systems, but as an aspect of the fundamental nature of what exists. This perspective doesn't contradict scientific findings. It reinterprets them. The laws of physics remain the same, but they're understood not as arbitrary rules imposed from outside, but as expressions of an inherent cosmic order, as patterns in a self-organizing whole, as habits of being that have evolved over billions of years. Under this view, the evolution of the cosmos from the Big Bang to the present isn't just a series of physical processes, but a journey of self-discovery. The universe isn't just expanding in space, it's exploring its own possibility space, expressing its inherent creativity through the formation of galaxies and stars, planets and organisms, cultures and consciousness, and human consciousness in EBVD. This perspective isn't an anomaly, an accident, or an epiphenomenon. It's the universe becoming aware of itself through a particular form, a localized expression of a capacity for self-knowledge that may permeate the cosmos itself. This isn't mere philosophy or poetry. It's a legitimate interpretation of the scientific data, one that makes sense of phenomena that materialism struggles to explain. The emergence of consciousness, the effectiveness of mathematics in describing physical reality, the apparent fine-tuning of cosmic parameters that allows for complexity, and life. But it's also a perspective with profound implications for how we understand ourselves and our place in the cosmic scheme. If you are not separate from the universe but a manifestation of its inherent creativity, if your consciousness is not just a product of your brain but an expression of something more fundamental, then your relationship to existence itself changes. You're not just in the universe. You are the universe, experiencing itself from a particular viewpoint, at a particular scale, for a brief moment in cosmic time. This recognition doesn't diminish the uniqueness of your individual perspective, the preciousness of your particular experience. If anything, it enhances it. Your consciousness, your capacity for wonder, your ability to question and explore. These aren't incidental features of an indifferent cosmos, but essential expressions of what the universe is and does. In you, yes, you, reality has evolved. The capacity to contemplate itself, to wonder about its origins and nature, to create art and science and philosophy, to love and to suffer, to experience the full spectrum of what existence offers. Your consciousness isn't something added to the cosmos, but something the cosmos itself does, something it has been evolving toward for billions of years. And this brings us to perhaps the most chilling question of all. What if the universe is conscious, and we don't recognize its consciousness because it operates on a scale and a time frame so vast that we can't perceive it directly? What if galaxies are thoughts in a cosmic mind, stars the firing of its synapses, the expansion of space, the drawing of its breath? This isn't to anthropomorphize the cosmos, to suggest it has human-like thoughts or emotions. It's to recognize that consciousness may express itself in radically different ways at different scales and levels of organization. Just as a neuron in your brain doesn't comprehend the thoughts it helps to generate, perhaps we, as components of a larger cosmic system, cannot directly perceive the consciousness of which we are expressions. But through science, through philosophy, through art and contemplation, we may glimpse aspects of this larger consciousness. We may intuit patterns and meanings that transcend our individual perspectives. We may sense, however dimly, that we are part of something vaster than ourselves, something that thinks through us, feels through us, knows itself through us. This perspective transforms our relationship not just to the cosmos, but to each other and to all living beings. If consciousness isn't confined to human brains, but expresses itself through all of nature in various forms and degrees, then every creature, every ecosystem, every aspect of the natural world has an intrinsic value beyond its usefulness to humans. Each is a unique expression of the universe's inherent creativity, a particular way in which the cosmos experiences itself. And if we are all manifestations of a unified whole rather than separate entities, then the boundaries between self and other become more permeable, more fluid. Your joy is my joy. Your suffering is my suffering. Your flourishing is my flourishing. Not metaphorically, but literally, for we are not truly separate beings, but interconnected nodes in a vast cosmic web, different expressions of a single creative process. This doesn't mean we lose our individuality or the distinctiveness of our personal experience. It means we recognize that our individuality exists within a larger whole, that our separateness is relative rather than absolute, that our boundaries are more like membranes than walls, permeable, dynamic, evolving, and this recognition changes everything. It changes how we relate to ourselves, to each other, to the natural world, to existence itself. It changes what we value, what we strive for, what we understand as the purpose and meaning of our brief lives in this vast, ancient cosmos. If you are the universe experiencing itself from a particular viewpoint, then your purpose isn't something imposed from outside, but something you discover through living fully, through exploring your unique gifts and capacities, through contributing to the ongoing evolution of consciousness in whatever ways align with your deepest values. And if consciousness is fundamental rather than emergent, if awareness is woven into the very fabric of reality, then perhaps what we experience as death is not an ending, but a transition, not the extinguishing of a light, but the dissolving of a wave back into the cosmic ocean from which it arose, not the cessation of experience, but the expansion of perspective, the liberation of awareness from the constraints of a particular physical form. This doesn't mean we should embrace fanciful notions of personal immortality or disregard the preciousness of our finite lives. It means recognizing that what we are in our deepest nature may be more enduring, more unconditioned, more vast than the temporary configuration of matter and energy that we identify as myself. The smallest thing in the universe and the largest, The quantum and the cosmic, the momentary and the eternal, the material and the conscious, may be aspects of a unified whole that transcends, yet includes all dualities. A reality that is neither one nor many, neither dead nor alive, neither mindless nor mindful in the ways we understand those terms, but something so far beyond our conceptual categories that we can only approach it through paradox, through poetry, through the direct experience of being present to the mystery of existence itself. As our journey together concludes, I invite you not to settle for easy answers or comforting certainties. The cosmos is too vast, too ancient, too strange for our limited concepts to fully capture. It exceeds our categories, transcends our understanding, defies our attempts to reduce it to something manageable, something that doesn't threaten our conventional sense of reality. Instead, I invite you to cultivate an attitude of wonder, of open-minded exploration, of reverent receptivity to the mystery that surrounds us and permeates us and constitutes our very being. I invite you to hold your theories lightly, your conclusions provisionally, your certainties with a touch of humility. For the truth is, we don't know what lies at the foundation of reality. We don't know what the smallest thing in the universe is made of, or whether that question even makes sense. We don't know whether consciousness is produced by brains, or whether brains are instruments through which a more universal consciousness expresses itself. We don't know whether the cosmos is fundamentally physical, mental, or something that transcends both categories. But our not knowing isn't a failure. It's an invitation to wonder, to curiosity, to the recognition that reality may be far stranger, far richer, far more alive than our conventional models suggest. It's an invitation to approach existence not just as something to be explained and controlled, but as something to be experienced and participated in, not just as an object of knowledge, but as a living mystery to be engaged with one's whole being. The greatest scientists have always understood this. Einstein spoke of the mysterious as the source of all true art and science, the experience of which he considered the most beautiful thing we can experience. Heisenberg acknowledged that the first gulp from the glass of natural sciences will turn you into an atheist, but at the bottom of the glass, God is waiting for you. Wheeler suggested that behind it all is surely an idea so simple, so beautiful, that when we grasp it, years, centuries, or millennia down the road, we will all say to each other, "How could it have been otherwise?" These weren't expressions of defeat or retreat into mysticism. They were recognitions that our maps are not the territory, that our models are not reality itself, that the cosmos exceeds our capacity to fully comprehend it through any single framework or perspective. So I leave you with this invitation. Hold the question. Carry it with you. Let it work in you. What is inside the smallest thing in the universe? What is the nature of reality at its most fundamental level? What is consciousness, and what is its relationship to the physical world? What are you beyond the labels and categories you've been given? Don't rush to answer. Don't settle for pat solutions or dogmatic certainties. Let the question open you to wonder, to curiosity, to the recognition that you are part of a reality far vaster, far stranger, far more alive than you might have imagined. And perhaps, in that openness, in that receptivity to mystery, you may find not just intellectual understanding, but a deeper knowing, a direct recognition of your intimate connection to all that exists, a visceral sense of being not just in the universe, but of it, a lived experience of what ancient wisdom traditions have pointed to when they speak of enlightenment, awakening, or self-realization. For if the smallest thing in the universe isn't a thing at all but a relationship, If reality at its core isn't made of objects, but of patterns of connection, if consciousness isn't produced by matter, but woven into the very fabric of existence, then the path to understanding lies not just in analysis, but in synthesis, not just in taking apart, but in putting together, not just in observation, but in participation. And perhaps the most profound discovery awaiting us isn't something out there in the distant reaches of space or deep in the subatomic realm, but right here, in the immediacy of conscious experience itself. The one reality we know directly, the ground of all knowing, the substrate of all experience, the mystery that we don't just contemplate, but that we are. As you go forward from this exploration, I invite you to look at the world around you with fresh eyes. See the stars not just as distant balls of plasma, but as ancient lights that have journeyed across vast reaches of space and time to reach your eyes. See the Earth not just as a planet, but as a living system that has supported the evolution of consciousness for billions of years. See other beings not just as objects or resources, but as unique expressions of the same cosmic creativity that manifests through you. And see yourself not just as a physical body or a psychological identity, but as a localized expression of a creative intelligence that permeates the cosmos, as a unique perspective from which the universe contemplates itself, as both infinitesimally small and infinitely significant, a momentary configuration of cosmic energy and a center of awareness through which reality knows itself. The cosmos unfolds around you and within you. Galaxies spinning, stars exploding, planets forming, life evolving, consciousness deepening. The same forces that move celestial bodies move the thoughts in your mind, the blood in your veins, the electrons in your cells. The same creative intelligence that shaped the cosmic web shapes your understanding of it. So I ask you one final question, perhaps the most chilling of all. If the universe is infinite, as some theories suggest, doesn't that mean that somewhere, right now, there's another you contemplating these same mysteries? Not an exact duplicate. Quantum uncertainty prevents that, but a variant. A variation on the theme that is you, a different expression of the same cosmic pattern. And if time is a dimension like space, if all moments exist equally in a four-dimensional block universe, then there isn't just one version of you but many, spread out along your timeline from birth to death. The you of 5 years ago, the you of yesterday, the you of this moment, the you of tomorrow, all existing simultaneously in the timeless whole of space-time. These aren't just mind games or thought experiments. They're serious implications of our best physical theories. They suggest that your sense of being a single, continuous self moving through time may be as much a useful approximation as the apparent solidity of matter. Not false, but incomplete. A practical interface with reality rather than reality itself. And so we come full circle, back to the foundational mystery. What is inside the smallest thing in the universe? Perhaps nothing. Perhaps everything. Perhaps the question itself is based on assumptions that don't hold at the deepest levels of reality. Assumptions about things having insides, about reality being composed of objects with properties, about space and time being fundamental rather than emergent. Perhaps the smallest thing isn't a thing at all, but a happening, a process, a pattern of relationship. Perhaps what we call matter is just energy organized in particular ways, and what we call energy is just space-time curved in particular ways, and what we call space-time is just information structured in particular ways, and what we call information is just distinction, differentiation, the capacity to be one thing and not another. And perhaps that capacity for distinction, for being this and not that, is also the root of consciousness itself, the ability to register difference, to respond selectively to the environment, to process information. Perhaps awareness, in its most basic form, is just this capacity for distinction-making, for information processing that exists throughout the natural world in various forms and degrees.